Pierre Delay. Pierre is from Vinci Group and especially Vinci Autoroute and Leonard. Leonard is the, let's say, innovation foresight platform of the Vinci Group. And Pierre is a director for connected autonomous and electric mobility. And we will discuss with him about the electric road use case for long range freight. Pierre, the floor is yours.
Thank you very much, Xavier. You have said it all. So I don't need to present that slide because Xavier said everything that is on it. I will talk about electric road systems, very much in line with the previous presenters. I'm very humble to present this after them. Just numbers. Mr. Lebeau has already given some numbers. I will give you our numbers, the highway numbers. In France, about a third of the national greenhouse gas emissions come from the transport sector. The vast majority of these come from the road. The waterways, aviation is only a fraction of this. And so 94, 95% come from the road. And within the road emissions, 20% are emitted on the highway. So in France, about 6 to 7% of the national emission, all industrial sectors combined, are emitted on the highway. Us, Vinci Autoroute, we operate about 40% of the national highways. So just on our network, about 3% of the national French emissions are being emitted. So it is a very serious challenge that we take very seriously, especially so that the role of the road to transport goods and passengers will continue to be important. Yes, there will be some modal shift, as was said previously. So today, about 85% of goods and passengers are transported by the road. This will go down, and this is a good news. But according to the predictions, this will go down to about 70, 72% by 2050. So still by then, the vast majority of goods and passengers will go through the roads. So this is why we really need to decarbonize all the road usages urgently. So how do we do that? Of course, tomorrow mobility will be mainly electric. I say mainly because the challenge is so big that there will be different solutions. There will be hydrogen, there will be liquid biofuels, there will be biogas, yes, but the mainstream solution, the mass market solution, we believe will be electric for all vehicle categories. But electric vehicles, battery electric vehicle, which is the ones being developed today, of course, for passenger cars, but also for trucks. The next generation of trucks are all coming with batteries. They come with their set of drawbacks and inconvenience. Most of these inconveniences are linked to the batteries. So we need also to address these challenges. We don't need to only focus on decarbonization and zero emission, but also address all of these other challenges of tomorrow's mobility. So what are the challenges of batteries? Some are operational, I would say. Obviously, limited range compared to the combustion engine vehicles. Downtime for charging. We even see some studies that point out the fact that we will need to increase the fleet of trucks to provide the same service, to transport the same amount of goods. So, of course, we don't want that. Reduction of payload. Yes, regulation will maybe allow you to not take into account that many tons of batteries because it is part of the vehicle, etc. But still, physics is physics. A battery is heavy. So the more battery you transport, the less payload you can transport. And payload is at the heart of the business model of transporter. And acquisition cost. I don't have the number for trucks because electric trucks are still rare, I would say, but you know that for passenger vehicles, about a third of the price of a battery electric vehicle is the battery itself. So for a truck with a big battery, that will be even more. It might be 40%, even 50% of the truck cost that would be linked to the battery. So it would drive the cost of the truck up, and obviously the acquisition cost of the trucks is also at the heart of the business model of transporters. And obviously, there are other types of challenges with batteries, especially with big batteries for trucks. These are environmental challenges. Mr. Lebeau explained previously the environmental impact, the footprint of electric vehicles before they're being driven. So, of course, this is mostly linked with extracting the raw resources to produce the batteries, refining them to a level of purity necessary for lithium-ion batteries, assembling the cells, assembling the packs, etc. So a passenger a battery electric vehicle with a big battery, let's take 100 kilowatt hour, emits before it's even being driven between 10 and 20 tons of CO2. A truck that has 800 kilowatt hour of battery, so eight times this, would emit a lot of CO2 before being driven. Then another challenge, the availability of the raw material itself. So that's just an example from the IEA, where you see the production and demand of lithium in this case. If you take the average between the two demand scenarios from the IEA, so the yellow curve and the red curve, you will see that we're good until 2025, 2026. But later on this decade, we may not have enough production of lithium to address the overall demand. This is not caused by a lack of resources, but by a lack of the production, refining and production of this metal. Other challenge is the mining sector. Extracting metal from the ground requires complex and energy-consuming processes, which have significant impacts on soil and local biodiversity, which are often irreversible. So we need to take this into account because this is a downside also of battery electric vehicles. And the last one that we don't often talk about is the land use. We have, all of us have some objectives to reduce the artificialization of our activities. So I think in France is we have to reduce the rate of artificialization by 50% by 2030, by 2031. But to put electric chargers requires space. I'll give you an example just to understand the ratio between electric chargers and fuel pumps. Within a 30-minute time window, with a fuel pump, traditional fuel pump, you can service 6 customers. Each of them need 5 times to fuel up their vehicle. And with that tank, they recuperate 600, 700, 800 kilometers. To do the same for electric chargers within the same 30-minute time window, if you need 6 electric chargers to service 6 customers, and within that time, with high-powered chargers, within 30 minutes, they recuperate 300, 350 kilometers. So you need 6 times more space, and they recuperate 2 to 2.5 times less kilometer. So there's a ratio between 1 to 12, 1 to 15, between the amount of space of parking spot in front of a fuel pump and parking spots in front of a charging station that you need. So we need to increase the parking lots, and this can be challenging to do, could be challenging to do when we have less artificialization objectives. So we need to address all of these challenges in addition to zero emission, in addition to decarbonization. One way to do this, as it was said before, is to be able to charge as you drive on the go to reduce the amount of battery that you need to embed in the vehicle, especially with the heavy vehicles. So we have talked about these different solutions, these different families of technical solutions, catenaries above the highway, with a pantograph installed on the cabin, conductive rail within the pavement, and with contactors coming down under the vehicle to touch the conductive segments, and induction. Induction is a coil under the pavement and a receiving coil under the vehicle, and wireless charging. The benefit of the last two, according to us, is that they are in the ground, and hence they are theoretically compatible with every type of vehicle. Obviously, for trucks, this is the main target of electric road systems, the truck, but also with buses, with light utility vehicles, with passenger vehicles. That's very important because doing so, we maximize the battery reduction capacity enabled by dynamic charging for the maximum number of vehicles. So we have the maximum environmental impact. I think this slide should not be presented by me, but maybe by Mr. Lebeau, because it's coming from the government, from the DGITM. Back in 2021, the Ministry of Transport has done a study on the benefits of electric road systems and came to these big conclusions. So the CO2 reduction benefit compared to electric trucks with batteries, with bigger batteries, but not capable to charge as they drive. Electric trucks, ERS trucks, can reduce overall CO2 emissions by 64%. So it is very significant. And we're not talking about 5-10%, we're talking 64% compared to electric trucks that are already zero emission. Also, if we look at the battery reduction potential of ERS, obviously, if we divide the size of these batteries by a ratio of 3, in this case, we save a lot of material. So the lithium, the iron, the phosphate, the nickel, the cobalt that are in the batteries. So we need way less over the lifetime of the truck. So the environmental benefits are huge. Then I would say business benefit or jobs benefit. It was mentioned in these reports that are public. You can look them up online. That to address the entire French territory, 9,000 kilometers of ERS lane should be built by 2035. This is very ambitious. So it's good to have an ambitious plan, and that is especially good because it would reduce the imports on raw resources and batteries that come a lot from Asia today, and it would accelerate faster the creation of local expertise in France and in Europe, which we need for strategic independence, industrial and energy independence. So obviously, France is not the only country thinking about ERS. There are many countries in the world experimenting ERS as we speak. I would say that in Europe, Sweden, Germany, and France are the most active, and the rest of the world, the US are also very active. In the US, there's about 10 different projects ongoing on induction in different states. So the US is looking at ERS pretty seriously. What do we do, us, Vinci? We have one of the projects that was mentioned in the very beginning. Our ERS project is called Charge as you drive, and we're gonna test two technologies. The induction one, this is technology developed by an Israeli company called Electron and manufactured by a French company, Hutchinson. So this is induction. So we put the coils in a trench at a depth of 10 centimeter, and you see here how we connect these coils to a roadside electric shelter, and then we pour asphalt back onto the coils, and then we just compact the asphalt, and then here you go. You have an induction lane. And what is very good about this technology is that there's no visual impact. It's completely transparent. You cannot even tell if a road is equipped or not. So from a user experience point of view, it is very elegant. And the second technology that we're going to test in our project, and we're going to do that on the highway, in open traffic highway. It's on the A10, it's southwest of Paris. Is a conductive rail. So you see here, we have to do a small trench. Not that big, 40 centimeter wide, 5 centimeter deep. So it's really not that large. We put a rail in it, and then we connect this rail to an electric shelter that you see here. The shelter is, of course, connected to the grid. And then under the vehicles, you have different types of collectors. You saw here that's one version of collector, but this company, which is a Swedish company called Ellenroad, has now different types of collector, comes down in contact with the rail. So in conclusion, electric vehicles, yes, yes, yes. Of course, we all in favor of electric vehicle. We need to accelerate electric vehicle. We have no choice. The decarbonization needs to be addressed right now, actually yesterday. But we don't want to do that by creating new problems. So not with big batteries. We want to find frugal solution. Electric mobility needs to be frugal. So we need to find smarter ways to do electric vehicles to reduce all the downsides, all the inconvenience of big batteries, whether they are operational, whether they are economical, more expensive, whether they are environmental. So that's the promise of electric vehicle, of ERS, electric vehicles, yes, but in a frugal way. Thank you very much.